Today's video is on complex power series, and in today's video I am going to solve a problem related to the Taylor series. And now in this video we have to find out the Taylor series expansion of cos hz around z is equal to pi I. Clearly here f of z value is given as cos hz and our a value is given as pi I. As you know that according to the Taylor series, so what is our Taylor series expansion? According to the Taylor series, we have an expansion as f of z is equal to, this is f of a plus this is z minus a by f dash of a plus this is z minus a whole square by 2 factorial into f double dash of a plus this is z minus a whole cube by 3 factorial into f triple dash of a plus and so on. Now if I substitute f of z as, so what is our f of z? F of z as cos hz, and in place of a as pi I, see what happens here. So this will become f of z is equal to cos hz. So this is cos hz is equal to, what is f of a? That is f of pi a plus this value is z minus pi a into f dash of pi I. Next one, this is z minus pi I whole square by 2 factorial into f double dash of pi I plus this is z minus pi I whole cube by 3 factorial into f triple dash of pi I plus and so on. So this is I. So now we need the values of f of pi I, f dash of pi I, f double dash of pi I, f triple dash of pi I. Now let's get started to solve that. So what is f of z? So f of z is nothing but cos hz. F of z is equal to cos hz. So in place of z, if I keep a pi I, then see, this will be cos h pi I. Now clearly I'll tell you one formula, that is cos of hyperbolic function of zi can be written as. So if you consider I as a negative sign, please remember, so cos of minus theta can be written as plus cos theta. So here I will be neglected and clearly you can write only trigonometric function as cos z. So this is hyperbolic function. So this is trigonometric function. So this is the formula, please remember. And sin hzi can be written as, so remember sine of minus theta is equal to minus sine theta. So minus comes out here also, I comes out, and clearly only trigonometric functions sin z. So these two are very important for solving this one, and here I am going to apply here. So if I consider this as a negative sign, please ignore it and write only the trigonometric function as cos pi. So cos pi value is minus 1, and therefore we got the value f of z as, see, so f of pi I value we got as minus 1. And clear? And next one, we need the value of f dash of pi I. For that we have to make a derivative for this. So f dash of z, see here, for cos hx it will be sin hz. Cos hz, this will be sin hz. For sin hz, this will be cos hz. There is no negative sign for the hyperbolic function, and therefore f dash of pi I. So in place of z, if I keep pi I, this is sin h. This value is pi I. Clearly, sine of minus theta is minus sine theta. So you apply that one. So this I comes out, and only the trigonometric function, that is sine pi. So hyperbolic turns to a trigonometric function, that is sine pi, and therefore pi value is 0 and this value is 0, and we got the value of f dash of pi I value as 0. Clear? And the next thing here is we have to apply a derivative for once again, that is z. So for sin hz, this will be cos hz. So if I apply z as pi I, so this will be cos h pi I. So remember, I ignores, and this will be only cos pi. The value here is minus 1. Therefore, we got the value f double dash of pi I value as minus 1. See here, cos of h pi I. Hyperbolic function turns into trigonometric function and I will get ignored according to this formula. And next one, third derivative. So after applying third derivative, it is also very easy. So for cos hz, this will be sin hz. So f triple dash of pi I value is equal to sin h. In place of z, we have to write pi I. So I comes out and only the trigonometric function comes. That is I into 0. The value here is 0. And therefore, the triple derivative of pi I value, triple derivative of pi I value is again 0. So we got these values, and if you keep on calculating, we'll be getting some more. So these are enough. First one is f of pi I value. F of pi I value is negative sign, and f dash of pi I value is 0, and f triple dash of double dash, f double dash of pi I value. So this is double dash of pi I value is negative, and f triple dash of pi I value is 0. So what is this Taylor's series expansion? Taylor's series expansion is this: f of cos z is equal to the whole thing you have to write, and we have to substitute all these values. And here I'm writing, that is cos z, cos hz value is equal to f of pi I. So f of pi I value is negative sign, plus this is z minus pi I into f dash. F dash is 0, plus z minus pi I whole square by 2 factorial into negative sign, and again 0, plus, and so on. And therefore this can be written as cos hz is equal to minus 1 minus, this is z minus pi I square by 2 factorial. So if I keep on writing, this will be power 4 by 4 factorial, and so on. So cos hz can be written as, if I take minus common, if I take minus common from all these, and can write as sigma n is equal to 0 to infinity. So this will be 0 to infinity. This is z minus pi I power 2n. So these are all even powers. This is 2n by 2n factorial. Therefore, our expansion remains as, so cos hz value is equal to minus times of, this is a sigma n is equal to 0 to infinity z minus pi I power 2n by, this is 2n factorial. So this is how we have to solve. This is also so simple. First we have to take f of z as cos hz, and a value is pi I, and this is the Taylor series expansion. In z, f of z, we have to keep cos hz, in place of a we have to pi I. So later we have to calculate f of pi I, f dash of pi I, f double dash of pi I, f triple dash of pi I. So using this one, so this is so important. Cos hyperbolic function of zi can be written as, so we have to neglect I, write only the trigonometric function cos z. So in place of sin h zi, so we have to keep this I outside and write only the trigonometric function sin z. So if you keep it in brain, so it will be very easy. That is cos pi value is minus 1. So we got all the 4 values, f dash, f double dash, triple dash. So after substituting, we got only the even powers, and therefore sigma minus in of sigma n is equal to 0 to infinity z minus pi I power 2n by 2n factorial. So please take a screenshot, as it is requested by one student. So I am keeping like this. You can take a screenshot and copy. Thank you so much for watching. This is the most important question, repeatedly asked a question. So carefully practice, pass it on to your friends, and thank you so much for watching. And please check my playlist, and most of the videos will be very, very useful for you, and pass it on to your friends. Thank you so much for staying till the end.